Welcome to Space Graders. The universe is vast, mysterious, and full of potential. As humanity continues to push the boundaries of exploration, one of the most pressing questions of our time is, where should we establish our first extraterrestrial colony? For decades, Mars has been the poster child of interplanetary colonization, capturing the imaginations of scientists, engineers, and space enthusiasts alike. However, a compelling case can be made that our focus should shift to Titan, Saturn's largest moon. Titan, with its rich organic chemistry, thick atmosphere, and abundant resources, offers unique advantages that could make it a more viable candidate for colonization than the Red Planet. Mars is remarkable for being the most Earth-like planet in the solar system, with evidence of past liquid water, a day length close to Earth's, and the presence of diverse geological formations like Olympus Mons, the tallest volcano in the solar system, and Valles Marineris, a canyon system that dwarfs the Grand Canyon. However, its thin atmosphere and harsh radiation environment make it a challenging location for human settlement. Titan stands out among moons due to its dense, nitrogen-rich atmosphere, making it the only moon with a significant atmosphere in the solar system. Unlike any other world, it has stable liquid bodies on its surface, methane and ethane lakes, making it unique in chemical composition. Furthermore, Titan is the only place other than Earth known to have a full hydrological cycle, though it operates with liquid methane rather than water. One of Titan's most striking advantages over Mars is its dense atmosphere. Composed primarily of nitrogen with a small percentage of methane, Titan's atmosphere is about 1.5 times thicker than Earth's. This thick atmosphere provides excellent protection from harmful cosmic radiation, a major concern for human habitation on Mars, where the thin atmosphere offers little shielding. On Mars, settlers would need to live underground or in heavily shielded habitats to avoid deadly radiation exposure. Titan, on the other hand, provides natural protection, making surface habitation more feasible and reducing the complexity and cost of constructing safe living environments. Mars, while relatively hospitable by space standards, is still an extreme environment. With an average surface temperature of about -63 degrees Celsius, -81 degrees Fahrenheit, it presents significant challenges for long-term habitation. Titan is even colder, with temperatures averaging -179 degrees Celsius, -290 degrees Fahrenheit. But its thick atmosphere mitigates some of the harsh effects of space weather, reducing the dangers posed by solar storms and cosmic radiation. Titan's low gravity, about 14% of Earth's gravity, could pose physiological challenges, much like Mars's gravity, 38% of Earth's. However, Titan's dense atmosphere allows for unique solutions, such as the potential for human-powered flight using simple winged suits or drones, a feature that Mars lacks. Both Mars and Titan have substantial water reserves, but they exist in different forms. On Mars, water is mostly found in polar ice caps and underground reservoirs, requiring extensive energy to extract. Titan, on the other hand, has vast liquid hydrocarbon lakes composed of methane and ethane, alongside potential water ice beneath its crust. This abundance of organic molecules provides a ready source of fuel for energy generation. A colony on Titan could leverage these hydrocarbons to create energy-rich compounds, making it possible to develop a self-sustaining fuel economy on site rather than relying on supplies from Earth. Additionally, Titan's surface contains complex organic compounds that could be useful for producing plastics, fuels, and other materials necessary for construction and survival. Unlike Mars, which lacks abundant hydrocarbons and requires more extensive mining for resources, Titan presents a more chemically rich environment that could be harnessed for human needs. One of the biggest challenges of Martian colonization is energy production. Mars receives only about 43% of the sunlight that Earth does, making solar power less effective. While nuclear power is an option, it comes with risks and logistical complications. Titan, though even farther from the Sun, offers a different opportunity. wind and hydrocarbon-based energy. The thick atmosphere supports consistent winds, making wind turbines a viable energy source. More importantly, the liquid methane and ethane lakes could serve as a potent energy source, fueling reactors or generators to sustain a colony. This could make Titan energy independent much faster than a Martian settlement, which would need to rely heavily on imported or extensively processed resources. Titan's low gravity presents another unexpected advantage: easier launch and transportation of materials. Escaping Titan's gravity well would require significantly less energy than launching from Earth or even Mars. This means that Titan could serve as a future fuel depot or staging point for deeper space exploration. A Titan-based colony could facilitate interplanetary travel by acting as a refueling station for spacecraft headed further into the outer solar system, a role Mars is less suited for due to its higher gravity and lack of liquid fuels. While Mars has captivated public attention, its challenges are significant. The planet's thin atmosphere, lack of protective shielding from radiation, and limited resource availability make colonization efforts exceedingly difficult. The dream of terraforming Mars, modifying its environment to make it more Earth-like, is a daunting and likely century-long endeavor. Titan, on the other hand, already provides a more naturally protective environment and an abundance of resources that could support human habitation with fewer drastic changes. Its thick atmosphere, chemical richness, and potential for in situ fuel production make it a prime candidate for long-term colonization. Additionally, while Mars is closer to Earth, taking roughly 6 to 9 months to reach, the technical challenges of survival make its proximity less of an advantage. If the goal is to create a truly self-sustaining extraterrestrial colony, Titan presents a better long-term investment. Titan and Mars are both fascinating worlds, each with unique qualities that make them potential candidates for colonization. However, when considering long-term sustainability, radiation protection, and resource availability, Titan emerges as the stronger candidate. The thick atmosphere, liquid hydrocarbons, and energy potential provide a compelling case for shifting our colonization efforts away from Mars and toward this distant yet promising moon. What do you think? Are you more intrigued by Mars or Titan? Do you believe humanity should pursue colonization on either of these worlds? Or should we focus on space stations and orbital habitats instead? Let us know your thoughts in the comments. If you enjoyed this discussion, give us a thumbs up, subscribe to Space Graders, and stay tuned for more in-depth explorations of our cosmic neighborhood. Thanks for watching.